morning, everyone. On behalf of the ISO, I'd like to welcome you to today's stakeholder meeting to discuss the Demand and Distributed Energy Market Integration Working Group. My name is Christina Guimera, representing ISO Stakeholder Affairs. Next slide, please. Just a reminder that today's call is being recorded for informational and convenience purposes only. Any related transcriptions should not be reprinted without the ISO's permission. And just a reminder to please keep your comments professional and respectful today. Next slide, please. To ask questions during the meeting, you can open the participant and chat panels on the bottom right. You can then raise your hand by selecting the raise hand icon, or if you joined audio only, please press *3 on your device. And please remember to state your name and affiliation first before making a comment today. And you can also send comments and questions via chat to all panelists or to myself. And if you run into any technical issues today, please contact Inteller Events, the host. Next slide, please. This is a visual representation of where we are in the stakeholder process. Here we are at the beginning of the proposal development stage. Next slide, please. And today's agenda will begin with a discussion on introducing models for pumped storage and participating load by Jill Powers and Ansel Lundberg. Then we will go through a series of stakeholder presentations by Northern California Power Agency, Portland General Electric, and the California Department of Water Resources. Thank you very much to our stakeholder presenters for joining us here today. Then we will take a brief break before launching into a stakeholder discussion on the draft problem statement formulation, and we will then wrap up for the day with next steps. And before we get started today, I'd also like to note that we have a timeline posted on our initiative webpage for the remaining themes, and we will also be highlighting this during our next steps today. And today we are focusing on enhancing demand flexibility options. So with that, I will turn things over to Jill Powers, the Policy Development Manager at the ISO. And if we could please move to the next slide.
All right, thank you, Christina. This is Ansel Lundberg and Jill Powers and Matt Fulton at the ISO. So we can just touch on this slide briefly to kind of take stock of where we are. We issued a working group schedule as a part of the market notice for this meeting, and so we encourage stakeholders to take a look at that, and we're trying to provide some certainty as far as what our scheduled meetings will be going forward. We have, obviously we are in the process of developing our problem statements through the buckets of different issues that have been included in the discussion paper. And we're also trying to kind of talk through those problem statements and provide a little bit of feedback from the ISO so that we can prepare those statements into something that will help us move into the policy development phase later this year. So that will allow us to develop solutions based on those problem statements, and that process and timeline is updated based on the latest policy roadmap that was issued and revised in May. So today, just highlighting this iterative process that we have been working through the last several meetings as we work through these problem statements. Today's agenda, as you saw from Christina, is mostly focused on hearing from our stakeholders on some of the key issues that we identified in this section of the discussion paper. We also posted a revised discussion paper with some revised problem statements from our previous discussions on performance evaluation methodologies, and we will do that, continue to iterate on that discussion paper as we work through these buckets of issues. So today we are focusing on demand flexibility in the form of participating load and related participation models. So Jill is going to give a very high-level review of our current policies regarding participating load, and then we will hear from our stakeholders. So I think I'll hand it to Jill, and we can go to the next slide.
Next one. Okay, there's another slide for you.
Oh, great. So I believe I covered most of this.
Those are the things we'll be covering.
Yes, we'll be hearing, these items at the bottom of the slide are proposals that were produced through the 2024 stakeholder catalog process and have been identified as relevant to the Demand and Distributed Energy Market Integration Working Group. And so we look forward to exploring stakeholder perspectives on these issues and as we move into this theme of enhancing demand flexibility market options. All right.
Right, so those are the three themes, the three topics that we'll be discussing today.
Yeah.
Hydrogen electrolyzer participation, representation of DR through base schedules, and participating load modifications. Okay, great.
Excellent.
Which are really new and not as well understood by our stakeholders. So that's why, hopefully that's the next slide. So
yeah, we can go to the next slide.
We can go to the next slide, I think. Okay, so that's why, this is Jill Powers, and we wanted to take a few minutes just to help level set all of our stakeholders on some additional participating models that we haven't gone through and done some, introductory educational introduction of them. So if we go to the next slide, I do want to highlight that we had, for our performance evaluation methodology theme, we talked about, some of these participation models, and in particular, performance evaluation methodologies really apply to supply-side DR, and this is where we talked about the models for reliability demand response, proxy demand response, DER aggregations, and non-generating resource. We also did have some presentation that did touch on some of the options, participation option that's available for our WEIM participants. We kind of term it as load forecast adjustment, also known as non-participating, load modifying, non-market participation. But if we go to the next slide, I wanted to introduce another model, not given as much attention, but it is a model, and it's a pretty, powerful model that's used for pump storage resources and large participating loads. I, again, just wanted to go over high level. If we need additional education on this, then we are prepared to really dig deep into it. But I wanted to bring it to the attention of stakeholders because I think you will hear from those, at least one of our presenters will really get into some detail as to how they utilize this particular model to represent either their pump storage or their participating load and some of the issues related to it. So first and foremost, participating load is an entity providing curtailable demand that has executed a participating load agreement. And this is different from our other models like PDR and the load forecast adjustment, which do not have to execute a participating load agreement. The curtailment of these participating loads is similar to it being considered like PDR as a supply side resource. So it's increasing electricity within the optimization. It's seen as a supply or a generator. To date, most participating loads are pumping loads. Now, participating load curtailment will occur through a real-time dispatch, and it's achieved when that curtailable demand through this model is offered to meet requirements for non-spinning reserve or to balance imbalance energy. There's three types of participating load. As mentioned, pumping load is a participating load, and it's associated with a pump storage resource, an actual resource that has both gen and load. It's a single participating load, can be a pumping or a non-pumping load, and it's associated with pump storage resource as well. And then thirdly, this model also provides for aggregated participating loads. And it could be aggregated pumping or non-pumping load. That is an aggregation of individual loads that operationally must be operated in coordination with each other. So, yeah, so those are kind of the distinctions. And if we go to the next slide. Next slide. Yeah, so this is, again, a representation. This table is actually within our BPM for market operations. There's a whole section on participating load within the BPM. And it kind of highlights kind of these differences. Sometimes I myself even get mixed up with some of the verbiage and the way that we're identifying it. But, you know, it really highlights they've entered into a participating load agreement, and then there's somewhat different load models, the models that are used. The first model being the pumped storage hydro unit model. And so the resources can be a pumped storage resource, as exampled with Helms or San Luis, or they could be a single participating load, like a single pump and a non-pump. So for the first representation, first model, it can support both the generation and pumping modes. And then again, the pumping mode is effectively a negative gen mode. So that's how the model is similar to the non-generating resource model. Now, if you just have a pump and you don't have the generation, then that's the second part of the model. Pump storage hydro unit model can facilitate just a load. So the generation capability of that particular model is just set to zero. And so again, the pump or that load is represented as negative generation. And then thirdly, again, this aggregated participating load could be pumping, could be non-pumping load. And again, has the ability to bid and schedule using this model, and can participate in the real-time market, providing non-spinning reserve. Has to be certified. And again, that non-spinning capacity is a representation of that generation through the dropping of the load, becomes a supply kind of gen quantity. So just wanted to highlight that, wanted to highlight this model, wanted to highlight kind of the different permutations of this model as we start moving into some of the discussion of large load participation. And again, one of our stakeholders today will be kind of, I think, digging a little bit deeper. They've had the experience in use of this particular model, and so they'll be representing some of the issues and problem statements related to it. If we go to the next slide, just wanted to provide links to reference materials. Again, we have a web page that has additional links, and it goes into the participating load. It also gives the link to the participating load agreement. Let's take a look at that. And then also wanted to highlight another reference material, being that of the BPM for market operations, section 2.1.6, as well as the BPM appendix. And I think the appendix was kind of interesting because it does get into some more of the technical aspects of this model. And it brings in some additional language talking about fictitious non-participating load, fictitious generator. But to me, in my mind, it's just kind of how the model is representing load and then representing that load reduction as a generator. But there's new terms within that section, but don't get thrown off by them. It also does get into the intertemporal constraint conversions, and this will really be, you know, about how it's modeled within the market. And these constraints are, you know, converted so it does look like a supply resource. And it identifies such things as load curtailment time, how it's really represented as a generator startup time, minimum load reduction time, how it's represented as generation minimum uptime, and things like that. So that's a good place to look at a little bit more about those constraints and the representation of the load and the load, the load participation constraints that need to be considered within the market. So again, just wanted to start the conversation today with a little bit of level setting for everybody that may not be as familiar with this particular model. Others will be talking today about the other models that we discussed, more of the PDR and the load forecast adjustment, but we wanted to take a little bit of time today on this particular model. And I mean, I could answer some questions, but I think the questions might be better answered by one of our stakeholders who will be doing the presentation and has had experience in this. But I could open it up for questions at this time, if there are any.
Jill, the only feedback we received so far in the comments, stakeholders asking if you could move closer to the microphone in the conference room.
Microphone. Oh, just right there. Sorry about that. Yeah.
You're coming through great. Thank you.
Yeah, unfortunately, I've gone through all the slides that I'm going through. But,
clarify.
Yeah, was there anything that you couldn't hear that kind of was not clear to you because I wasn't close enough to the microphone?
I think we were all able to hear you fine. It's just they wanted you'd be slightly closer. But I'm not seeing any other questions coming in at the moment. Oh, we just received a hand raised from Nadia Krantz. Go ahead, Nadia.
Hi, this is Nadia Krantz with PacifiCorp. Can you hear me okay?
We can, yes.
Okay, perfect. Good morning. Thank you for that presentation, Jill. I just had a clarifying question. If irrigation would fit into this participating load bucket that you just presented on?
It potentially could.
Okay. All right,
Yes.
that was my question. Thank you.
Yep.
Yeah, I think the aggregated participating load with multiple loads would be the relevant model.
Right.
So.
Aggregation. Okay, perfect. Thank you.
Now, I didn't present this, but I did want to note that there is this difference between this particular model and what we discussed in the PEM, or performance evaluation methodologies for the PDR model, and that is these are, I don't know if directly metered or they're individually metered loads. So they just use a meter. So there are still requirements, and if you go into the participating load agreement, it will reference the metering requirements for these type of resources as well. But as you can imagine, these are large pumping loads. They're directly metered. They settle through direct metering and not through a baseline methodology, as we've talked about within PDR.
Yeah.
Okay.
We just received another question in the chat from Eric Leon asking if you can provide any information on the conditions a provider or load would choose this pathway versus PDR or RDRR.
Well, from the PDR economic, I think RDRR would not, those type of loads are afforded a much different kind of participation kind of constraints than what would be under a participating load. The other difference is these loads are actually scheduling in the load as well as the load curtailment, versus when you get to PDR and RDRR, you're separating those that are forecasting and scheduling in the load versus the scheduling of the load curtailment. So this is more of an economic load scheduling that allows for curtailment of the load economically.
Thank you. And I'm not seeing any other questions at this time. So with that, I believe we will move to stakeholder presentations. First, we will be hearing from Northern California Power Agency.
Great, just doing a mic check, make sure you can hear me okay?
Yes, you're coming through great.
Excellent, great. Well, first and foremost, my name is Tony Zimmer. I am the Assistant General Manager here at Northern California Power Agency. I really appreciate the opportunity to present some of these high-level concepts today, but the focus of our discussion is really on how electrolyzers, hydrogen electrolyzers may participate in the California wholesale market. So if we could please jump to the the next slide in the presentation. Really through this at a fairly high level, my objective is to kind of discuss why we're here today. Spend a little bit of time on talking about the operating characteristics associated with electrolyzers and how they can be used to provide reliability services and other services to the California ISO markets, different possible market participation type models, and discussing different operational configurations, because this technology does provide some options in terms of how it's modeled and to provide services to the California ISO. So I guess jumping right into it, if you wouldn't mind to moving to the next slide. As was noted at the beginning of this discussion, Northern California Power Agency did submit a request into the California ISO stakeholder catalog process, indicating that we felt that it was important to work with the stakeholder group to develop rules that may speak to the unique operating characteristics of hydrogen electrolyzers, really with the objective of developing rules that recognize the different of operational configurations. And without getting into all the intricate details of how electrolyzers work, more or less the electrolyzers consume water and power, and they produce hydrogen gas that can then be stored and used for downstream consumptive purposes. The primary one, for example, that NCPA is focused on is utilizing hydrogen electrolyzers to produce hydrogen gas that can then be used as a fuel source for other participating generators that may be built or currently in operations. And I'll speak to an acute example of one of NCPA's projects where we're currently looking at building hydrogen electrolyzers that would produce hydrogen gas that could then be stored and then subsequently delivered and consumed or burned through an existing natural gas generating facilities. So really integrating hydrogen electrolyzers more in the context of not using that term in direct relation to other market designs as more of a hybrid or co-located design. Hydrogen electrolyzers also can operate independent from other generation facilities and act more as a dispatchable load. Whereby hydrogen electrolyzers are consuming power off of the grid to produce hydrogen. And we'll talk more about the operational flexibility of the systems, but they can be economically dispatched in real time by the California ISO to reduce that load consumption, to act as, I guess, as a participating load or as a dispatchable resource on the grid, or a variety of combinations. So in the context of the project that I'll be speaking to that NCPA is currently considering, we are looking at the possibility of installing a sufficient number of hydrogen electrolyzers where a portion of that facility would be dedicated to act as a fuel supply for the natural gas facility and enable us to really use that as a storage technology. And there could be a separate set of facilities installed at that location where the hydrogen electrolyzers really are just operating as a dispatchable load. In the context of this discussion being demand and distributed energy market integrations, I know the focus here is on how hydrogen electrolyzers could act as a dispatchable load, but we are kind of emphasizing that as part of this, that there are other abilities to use this technology really in the context of an alternative to storage. So you'll hear me speaking to that throughout this discussion. But due to those unique operating characteristics and the potential various combinations of how that technology may be used as standalone technology or as supplemental technology for existing facilities, we were reviewing the existing market rules described in the tariff and the business practice manuals today, and it didn't seem like there were existing rules that sufficiently address the unique operating capabilities or these various types of scenarios with clarity. So really our request as part of this ongoing stakeholder discussion is to work as a group to develop rules that speak to this technology specifically as a possible future augmentation to the tariff. Also, as part of developing those rules with any new technology, and I think this has been the case with other technologies over time. For example, I'll be referring to battery energy storage technology and associated rules, and variable energy resource operations that, in addition to establishing kind of technical rules to enable clear participation of this technology in the market, also looking at developing rules that do provide certain incentives to encourage further development of this technology, because we think that this flexible technology will be a key tool that the ISO will use as we look into the future to help manage further integration of renewables. So also have to keep in mind concepts related to developing rules that do encourage or incentivize further development and scaling of this technology for integrating into the market. So if you could please go to the next slide. As far as dispatchable or flexible operating capability, electrolyzers are very flexible. As noted, they consume power off the grid to produce hydrogen fuel. In the case of one of my examples where that hydrogen facility is paired with another generating technology, let's say, for example, an existing natural gas facility, that hydrogen fuel can be burned to then produce energy and dramatically reduce emissions associated with that downstream production, and the byproduct is actually carbon free. But the technology itself, in the context of either supplementing the operations of an existing facility or operating as a standalone technology, is very flexible. The facility can be effectively dispatched, turned on from zero operations to full load, or vice versa, reduced load in a very quick manner within a 10-minute time frame. So this technology should be able to provide spinning reserves, non-spinning reserves to meet those 10-minute dispatchable requirements. Also has quite a bit of flexibility in a very aggressive ramp rate, and should be able to increase or reduce production very rapidly, and therefore provide regulation services responding to 4-second AGC set points. In the context of hydrogen electrolyzers being used in combination with other generating technologies, and I'll speak to this in some of the key examples that NCPA is working on, where we are planning to install electrolyzers and then also install on-site storage. So as those electrolyzers are producing hydrogen gas, that hydrogen gas can be stored on site and then subsequently used. And so really kind of similar to a battery energy storage concept, where the batteries will charge and store energy that could be subsequently discharged and redelivered back to the grid to support reliability. Similar context here, where with the installation of storage capacity paired with an electrolyzer production, you could effectively store the fuel that's produced and use that fuel to provide services at a later point in time to effectively reshape the dispatch of source generation, which I'll describe. And these facilities, again, have the ability through SCADA control or other real-time technologies to respond and follow ISO set points or dispatch operating targets. And so they can look and feel and act as they're generating facilities, but more or less in the context of reducing production in more of a participating load concept or otherwise. And again, one of the things we think that this technology is really important is, in particular, if you compare this technology with existing or new dispatchable resources, in this case, for example, natural gas facilities that are already in place and operating today that would otherwise potentially have to retire come 2045, but could operate into the future with a different non-carbon emitting fuel source. This really speaks to this kind of missing dispatchable renewable resource that is referred to in a number of the kind of high-level studies that describe what will the grid need to include to enable us to achieve our carbon reduction objectives by 2045. There's always a general reference to the mysterious dispatchable renewable resource. In the context of that concept, an electrolyzer facility paired with an existing facility really does kind of meet that requirement, whereby the hydrogen fuel that's produced and stored can then be subsequently used to operate a very dispatchable, flexible facility that can operate during periods of time to support integration of other non-dispatchable renewable resources. You can go to the next slide when you get a chance, please. So the basic concept as far as how we anticipate based on our modeling of how the electrolyzers would likely run is during the course of a standard day. And I just grabbed this particular day off the ISO's reports for March 23rd. And in this particular circumstance, based on the amount of solar production is the predominant driver of this, the amount of solar production that was forecasted to be delivered to the grid. There were challenges during the middle of the day where there in fact were probably over generation conditions where solar generation may have been curtailed to support reliable operations of the grid. But the general concept here is that we're anticipating the hydrogen electrolyzers will run primarily during the middle of the day in response to the so-called belly of the duck curve, and in essence create additional load on the system that enables that solar or other renewable production during that time period to be delivered to support carbon reduction and to mitigate the risk associated with what will likely be continued curtailments of renewables during the middle of the day when that production is high. And during that period of time, more or less producing hydrogen gas that could be stored and then subsequent used to power other resources to respond to some of these aggressive ramps. In the context of hydrogen electrolyzers being operated as a standalone facility, those facilities are very dispatchable, so they have the ability to operate based on ISO control set point. And in those instances where additional demand on the system would help support system reliability, provide a sink for a lot of the renewable production on the system, those electrolyzers could operate. But if those electrolyzers needed to change operations by reducing their consumption of power off the system to follow ramp curves, then they are very flexible and could respond to those instructions. So the general concept here is they would be used in combination with other facilities, again, kind of as a storage technology, or could just simply be responsive to grid conditions and economic price signals, and basically dispatch similar to a generating facility, but as a reduction in its consumption use of the system. If you could please move to the next slide. This is where NCPA's real focus here. I know the goal of this discussion is talking more on the demand side, but really looking at electrolyzer technology to support the more of a long-term storage capability. Again, pairing storage with electrolyzers are really will enable these facilities to act as either short-term, mid-term, or even potentially longer-term storage facilities, similar to batteries, but perhaps with a longer storage cycle than a kind of a standard for our lithium battery. Really, the ability for the facility to store gas that could then be redelivered for subsequent generation is a function of the amount of storage that you construct on site. And again, it would enable kind of the reshaping of renewable production in the middle of the day to follow kind of those aggressive ramps in the evening to provide reliability support. You know, in the context of the projects that NCPA is looking at, you know, storage can be for a period as short as a number of hours or up to a duration of potentially 5 days. And in the context of a couple examples I'll show in pictures of the project that we're currently considering, we are evaluating the possibility of building sufficient on-site storage to hold up to 5 days worth of hydrogen gas produced that could then be used to run, for example, a natural gas facility on a 24-hour basis for a 5-day duration to respond to, you know, significant heating events that may span for multiple days or such. One of the key, you know, issues that, you know, we'd like the stakeholder group to consider, talking about the way electrolyzers can be used in different model configurations. In those cases where the electrolyzers are standalone facilities and are participating as loads on the system, then I think many of the rules that apply to participating generators could likely be kind of used or perhaps modified to some degree, but could be used for, you know, addressing how those types of facilities could participate. But in the context that electrolyzers are paired with existing facilities and operated more as a kind of co-located hybrid type structure where the electrolyzers are producing gas for the primary purpose of then supplying that gas to a downstream facility that will then generate power using that gas back onto the system, really acting as a storage technology, you know, to help it further encourage the development of this technology so that it becomes more cost effective and therefore scalable into the fleet. You know, we would like to explore with the balance of the stakeholders whether or not there should be specific rules that are applied to those two distinct configurations. And, you know, one example is, you know, and this was a rule that was put in place to also encourage further development of battery energy storage capability. But when batteries are charging from the grid and then subsequent discharging, during that charging period, batteries are not charged for transmission fees for utilizing the transmission system to consume power for the charging window and then subsequently discharging. So we would suggest or propose that in the context that electrolyzers are used in a combined strategy with other generating facilities for the purpose of providing storage capability, that similarly electrolyzers in that operational configuration should also be exempt or not subject to transmission charges to kind of really, again, encourage that technology and to really provide kind of a kind of an equitable treatment in terms of, you know, different technologies that can provide storage capability. If we can go to the next slide, please, I'll kind of go quickly because I know my time's somewhat limited, but there's some, you know, pictures here that give you examples for your future reference as to the general configuration of an electrolyzer project. We're in here, I'm not going to walk through each individual subcomponent, but gives you a general sense of the various parts of the facility that make up the facility design for your reference. If you could please go to the next slide. One thing really wanted to emphasize is that this technology does exist today. I'm sorry, if you can go to the next slide when you get a chance. This, in the context of NCPA's project we're working on, we've been working with Siemens Energy, who is just one of many manufacturers that produce electrolyzer technologies that are currently in operations today. For example, here's a reference to an electrolyzer set that was put into active production this year by Siemens to be used to support operations. And so this is not necessarily exploratory technology. It does exist, and there's a lot of investment being made to ensure that this technology becomes readily available for commercial operations. If you can go, please go to the next slide when you get a chance. Other kind of general information as to kind of operational criteria or details related to electrolyzers in the context of the project that NCEPA is considering. We are looking at an initial installation of approximately 60 megawatts of electrolyzer load. Here are some statistics on this slide that describe the conversion ratios for example, the amount of energy consumed that results in the amount of kilograms of hydrogen produced that then can subsequently be used for downstream generation purposes. And really the two feedstocks for the technology are power and water. And so here it also provides some general information that describes certain conversion rates. The third note here, in the interest of time, won't go into great detail, but that's a bit of a conservative estimate. We're anticipating that for a 60 megawatt electrolyzer set or a 60 megawatt load, that will produce approximately about 1,000 kilograms of hydrogen per hour. And so just give you some information to get a sense of the kind of conversion ratios as far as the power to fuel ratios. And just a couple of pictures to kind of wrap up the presentation here. If you can go to the next slide, please. The project that NCEPA is working on is, I'm sorry, if you could click to the next slide. Great. So here's a rendition of the current project that NCEPA is actively working on, whereby we would be installing, again, electrolyzer facilities with storage capability that would, consume power, produce gas, store that gas, and then subsequently provide or deliver that gas downstream to existing generation facilities. So this gives you a general sense of kind of rendition of that type of project. If you could please click on the next slide when you get a chance, and more specifically, to give you a true kind of real life operational case, NCEPA is actively working with the Department of Energy and other agencies to consider developing a project where we would be constructing and releasing to commercial operations an electrolyzer facility. And this particular picture is represented in the facility on the top part of the pictures circled in red, with the objective of delivering the hydrogen fuel produced by that facility to an existing natural gas facility depicted here in the bottom side of this picture. That is NCEPA's Lodi Energy Center. And the current turbine that's installed at that facility can burn a fairly aggressive blend of hydrogen. It's currently at a point where it can burn up to 45% blend of natural gas and hydrogen. And we're expecting that with certain upgrades that will be installed at that facility over the coming years, that prior to 2045, that facility would be able to burn a 100% delivery of hydrogen gas. So in this case, again, building on-site storage that could then be used to, produce hydrogen during the middle of the day when solar production is high, store that gas, and ultimately deliver that gas downstream to an existing natural gas facility that could then run during the ramping periods and over the course of the evening, producing zero emission output to support grid reliability. So with that, I think that wraps up my presentation. And again, I appreciate the opportunity to present some of these concepts, at least at a high level. Happy to answer any questions, now or throughout the course of the discussion today, and look forward to working with the California ISO and the balance of the stakeholders on concepts related to developing market rules that speak to the unique operating characteristics of electrolyzer facilities.
Thank you very much for your presentation, Tony. Does anyone have any feedback or questions regarding this presentation? I'm not seeing any questions coming in quite at this moment. Ansel or Joe, do you have any feedback?
Yeah, thanks, Tony, for presenting. Appreciate hearing NCEPA's perspective and what you're developing here. I have a question on slide 6 from your presentation.
Sure.
Could we go back to slide 6? Okay, so on this slide, Tony, you mentioned sort of this concept of storage, but I wanted to clarify, does this slide describe two different approaches to kind of the combination or distinct representation of a load and a gen? Can you clarify that? Does that make sense?
Yeah, no, that's great. No, I appreciate that question. And it kind of speaks to perhaps the original intent of our inquiry into the stakeholder catalog. I think in the context where I think there's two kind of operating conditions. One that may speak more acutely to the demand and distributed energy market integration discussion we're having now, where you have an electrolyzer, hydrogen electrolyzer project that is acting as a load and effectively consuming power off the system, but that can be dispatched or turned down, based on dispatch instructions from the ISO as a function of economics or otherwise. So one, model is more of a real-time production operation model, whereby the facility is being kind of redispatched by the ISO for reduced consumption, or perhaps providing operating reserves or regulating services by modifying the current operating set points of the facilities. And for example, in NCPA's current proposed design with our initial project, we're looking at about a 60 megawatt electrolyzer project, where at full production it would be consuming about 60 megawatt hours for production, and could be ramped down, or that reduction could be reduced down all the way to 7 megawatts, would be treated as, say, for example, a PMIN operating level for that facility. So the ISO would have flexibility to dispatch that unit anywhere between 7 megawatts and up to 60 megawatts, and vice versa. The effective speed of achieving kind of full operations from, for example, being in a non-operating condition, it's off. It can achieve 60 megawatts of demand within 10 megawatts, or similarly can reduce that within 10 megawatts, actually much faster than that, has a very aggressive ramp rate. And so that would be an example of just an electrolyzer acting as a participating load, ignoring the concept of storage perhaps, and just responding to real-time dispatch instructions. But our kind of other objective was really looking at this technology in a way that, while it is a load on the system, it really could be used as more of a storage type of facility, where, similar to batteries to some extent, where when they're charging, they're acting as load, and they consume power off the grid to store that power, then to be subsequently delivered or dispatched onto the grid at a future period in time. And so the other kind of really a key objective we have, and where this technology also could be extremely, in our opinion, useful for supporting system reliability, is how this technology could be paired with other generating technologies. So in the case of our project, basically, charging or producing hydrogen during the middle of the day when solar production is high, and we're looking for a home for that production. The gas can be produced and stored on site, and then that gas can then be subsequently delivered to that downstream coordinated technology, in our case, a natural gas facility that can burn hydrogen. And then that downstream facility could be dispatched to produce output similar to kind of discharging the battery back onto the system. So we were interested in kind of exploring both of those tracks. And I think, as an example of where the rules might be different in those two tracks, is for the kind of co-located hybrid type operations, where you're combining it with something else. Perhaps there's some interrelated operational details, linked to that paired facility, and in the context similar to batteries, to create incentives for the technology. Also, perhaps a different consideration as to whether or not the electrolyzer loads per se are subject to other types of fees, like transmission-related fees if they're operating in that configuration as compared to just operating as a standalone kind of dispatchable load.
Thank you.
Thank you.
That's very helpful.
And I'm also seeing a question from Colin Smith. You should be unmuted now, Colin.
Hi, thanks. Colin Smith from LEAP. Kind of a follow-up question to what Tony just said, and maybe also a question on the participating load presentation. You mentioned that if a hydrogen system is operated as a storage kind of facility, it could or perhaps should potentially be exempt from transmission fees the same way that, you know, a battery energy storage system is. If the hydrogen facility were operated as a participating load, as was just described, and it scheduled its load in the day-ahead market as well as its curtailment, is that configuration or that structure still subject to transmission fees? Like, are participating load systems, do they have access to, I guess the upshot is, do participating loads have access to wholesale market pricing, or are they still subject to like T&D costs when they schedule their load in the wholesale market?
That's a great question. As far as kind of the general market mechanics that apply to participating load agreements that, you know, may be subject to existing tariff requirements and existing underlying agreements, you know, I'll probably have to defer to the ISO to make sure I don't, you know, misspeak or represent anything in that general context incorrectly. But I think our kind of in the context of how that question applies to the concepts we're presenting here, I think that's one example of why, you know, we think the rules that, you know, may or may not exist today could be further developed and considered, because I think in the context of NCPA's proposal, to the extent that the hydrogen electrolyzers are just operating as more of a traditional participating load, my general instinct is that, you know, rules that apply in that context would likely be appropriately applied, you know, in that context to that type of hydrogen configuration, you know, subject to perhaps tweaks to speak to the technology details. But in the context that an electrolyzer project is being integrated in a different fashion for kind of a different useful purpose, really in that context, using it to provide a storage mechanism similar to maybe in the context of this example of batteries, then perhaps in those instances, kind of rules that speak to that unique operating construct would be appropriate. But again, as to the general rules that apply to participating loads, I'll have to defer to the ISO. I don't want to unnecessarily speak on that.
Thank you, Tony. And I'm not seeing any other questions coming in at this moment. So I think that concludes questions received for this presentation. Next, we will be moving on to a presentation from John Kitchen from Portland Gas and Electric. Over to you, John. We just lost him, I believe, so let me double check. If we don't have him, we will move on to the next stakeholder presentation. There we go. I see John. Could we please move him up, please?
I made it back just in time. Sorry about that. I had to drop for another meeting. So yeah. So anyways, I'd like to talk a little bit. I was asked to kind of review the potential option for base scheduling demand response. So I kind of want to recap on where we left off during the last meeting, kind of our proposals, and then get into comparing base scheduling options to a participating model. You can go ahead and go to the next slide, please. So these, this slide and the next slide are both just kind of, or actually they're the same slides from our previous presentation. And so just kind of wanted to recap there. Our point was really, if you look at PIMS, the performance metrics basically is like a pseudo meter for us. That's how I see it. So when you dig into how a traditional participating resource is framed in the market, there's not in the Terra for WEIM entities, which were under SCME, scheduling coordinator metering entities. There's not like specifics for how that metering is managed. And so that's actually kind of managed through the BPM and also through the SQMD plan. So SQMD being settlements quality meter data. So anytime we register a new resource, we're submitting that plan to CAISO stating, hey, this is the one line, this is what we have here. This is where these are the types of meters we have. This is how we're going to do the calculations for the meters if there are calculations. And then we come up to an agreement completely separate outside of the tariff. And so kind of wanted to use that as almost kind of like a benchmark as for our ideal state, if we could get to something like that for participating DR programs where we could come up with an agreement for the PIMS or for the baseline methodology that we're using for the different DR programs. So that was kind of the premise of this. One of the things too, the second main bullet point there about new functionality to scale, right? Our customer programs are changing, and I know all of your guys' are as well. So that's just something to think about too, because typically when you submit an SQMD plan, you need to update every time something changes, but we need something that's going to be scalable as our customer programs change. The base changes, either people are opting in, some people may opt out, or whatever the case may be. Another thing on here was the 10 megawatt threshold that currently exists for like PDRs that would require telemetry. So that was kind of something that would be nice to be able to drop that threshold for some of these programs. There may be some cases where that makes sense, but for a lot of these programs, we're not going to have telemetry. And so basically like what's going to happen is we're just going to have a bunch of like 9.9 megawatt resources that we could have just aggregated into a single one. And it's just going to make it so we're going to have more base schedules, more bids and stuff on resources when we could have combined them. And then the flexibility, obviously the DR programs aren't going to be the same every single time we call them. So there's going to be, there's going to be some dynamics there that we need to account for, which kind of goes with the participating resource, most participating resources anyways. And then the last two pieces here, just kind of some improvements that we've talked about for a little while now is issues with the load forecast not having feedback in terms of when we have a DR program. So it will see at the start of a program, it will see a load drop without any sort of corresponding reason why. And also when it returns, it sees the sharp load increase without having a reason why. And I know CAISO is already working on some things to fix that, but I just wanted to still include that in here as a point that we need to have some sort of way to represent these DR programs in the load forecast, so the load forecast doesn't just try to chase them down or up when they return. And then the last one on there is also, one of my thoughts there is the DR, we can do our best to forecast these DR programs, but I think everybody knows that it's there's so many variables there, it's hard to accurately predict them. So having something in place where we can make some adjustments, and I'm thinking similar to like how we do our we have the ability to, or the entity side, and BayOp has the ability to go in and make adjustments to VER forecasts. If we had the ability to do something like that in real time, that could be beneficial. There may be some programs where we don't necessarily get immediate feedback, but there are others where we might be able to, and I could see where that could be beneficial. If you could go ahead and go to the next slide, please. So this was just kind of another potential alternative, if that could be implemented quicker, or if we couldn't get to the point where we have participating resources. And we may even have programs, or I shouldn't say may, I know PGE has programs that aren't necessarily well suited to be a participating type resource because of their limitations. So another option here is allowing us to do something like make a non-participating model for them, where we could then go in and base schedule, and also still incorporate the ability to feed that base schedule back into ALFS, into the load forecasting system. So we hopefully avoid the issues that we've had with the load forecasts in the past. And then also the last point is also the same as the previous slide. Is it would be nice if we had a way to make some sort of adjustments to those DR programs, because the forecasts aren't necessarily going to be 100% all of the time. So, and then if you could go ahead and go to the next slide. So this is where kind of comparing, and these are just my thoughts, and I think where PGE sees these, so may not necessarily be 100% accurate, but this is just kind of my interpretation of it right now. So on the first point there about the market participation, I think it's pretty obvious that base scheduling is going to be non-participating, and so we have, PGE has a push from a variety of people, from higher up to even like our folks in our PUC and others would like to see demand response resources participating. So we kind of have this goal to be able to make them participating. So that's one drawback of the base schedules. The next line there is, easily scalable with customer enrollments. So if we just do a simple base schedule where we just, register basically a non-participating resource, it doesn't have a whole lot of details, we can clearly schedule that. With a participating model, I have a question mark in there, because that's something that would need to be thought through. I think we could probably derive something that is scalable and flexible, but that just needs to be taken into consideration. The third item on here about automation, this was kind of a big point for us, was being able to use existing tools and processes to represent these, rather than using the existing process that's pretty manual, involves submitting emails and then waiting for email responses back. And so either one of these solutions solves that problem for us. The fourth item on here is potential DR forecast feedback, which kind of talked about that. And I believe that that's feasible with both options. And then the improved transparency. So what I was getting at here is the way that it works today. We're submitting the load forecast off in an email, and then if the CAISO load forecasting team doesn't incorporate it, we're managing it off to the side. So we're entering the load conformance in BAYOP. But the point there is when we do that, our tools aren't matched up. So BSAP, the base scheduling aggregating portal or aggregation portal, doesn't see that position for the DR programs. And so in the event, like let's just say, just for ease of math, we had 100 megawatts DR event and CAISO did not incorporate it in the load forecast and we entered it into BAYOP. And BSAP, for us to come out perfectly balanced in the test results, BSAP would need to show that we were short 100 megawatts. And so there's the little discrepancy there. And then also in the other route, so that's if CAISO doesn't make the adjustment, if CAISO does make the load forecast adjustment, you know, then it's there, it's incorporated, but there's not necessarily any sort of indication other than just an email back saying, hey, we implemented this. So having either of those options kind of provides that improved transparency in terms of what's going on with our demand response event call. The next item on here is ability to adjust the resource schedule. And so that was one of the points that or actually on both of the slides I talked about that is, you know, it's not something that CAISO has implemented for these today, but I think it's something that's feasible, that we could do something like, again, like a load like the VER forecast adjustment, where if we start a DR program and we recognize that they're not performing to our forecast, or maybe they're actually performing better, having the entity have the ability to go in and make an adjustment to that, again, I think would be valuable. Then on here, following that, I've got the settlements data. So this is something that I think comes up for PGE on occasion. We get members from the PUC inquiring about it, as well as internally we have, you know, folks asking, hey, how did this resource perform? How are our DR programs doing? What's the market benefit since we can include them now? You know, today using the LFA model and also the base scheduling model, we don't have any sort of settlement data associated with that. So that's one of the drawbacks to the base scheduling option without being a participating resource. Whereas if it was a participating resource, we would have that settlements data. And I think did I see a hand go up?
Yes, we have a question in the chat as well as a call-in question. Would you like to go to questions for a moment?
Actually, I guess I've only got a couple more things, and then maybe we can switch to questions.
Okay.
So the last three items on here. So the next one is works with all PGE customer programs. So as I mentioned, we do have some programs that aren't flexible and may not work with a traditional participation model. So that is one place where the base schedule would have a benefit over participation model for us. And I do kind of have a question mark there because the very last one on there is about EDAM, right? And so as we talk about this, and you know, from my understanding, there's not going to be any base schedules in EDAM. It's going to all be bids and self schedules per se. So I don't know how that's been thought of, how these programs might be able to work with EDAM, especially programs that don't necessarily follow a like a normal participating characteristics. So I do have that question mark there in terms of that might be something that needs to be thought through in EDAM and maybe addressed. Not entirely sure, but the way that it stands today, not all of our programs would meet a typical participation model. Then the second to last one on there is I tried to word, this is kind of weird to word, but I kind of worded it in a way to give the base scheduling the green check there. But basically, you know, if we were to base schedule it as a non-participating resource, we wouldn't necessarily need to worry about PIMs. And so that would be, you know, that would be a lot easier to implement, whereas the participating model would require us to have some additional work needed on the PIMs in terms of how that's represented and come to an agreement. And then I already touched on EDAM in terms of no base schedules in EDAM, everything's bid and or bid with self schedules and whatnot. So I think we can go ahead and go to questions now.
First, we have a call-in user. If you could please state your name and organization, please, before you ask your question.
Yeah, this is Dan Williams from the Energy Authority. And first, just wanted to say thank you for the effort that PGE has been putting into this. I do agree that it's really important work, especially as we move towards EDAM and try to figure out a way for not just the entity BAs, but any of the sub-LSCs in the EDAM BA areas that have these types of programs that need to find a way to reflect them in the resource efficiency evaluation and then in the market more directly. And so I just, you know, really wanted to emphasize the importance of this and say thank you for all the work that PGE has been putting in. A question I had, though, is you kind of look at incorporation maybe through the load adjustments right now, and then thinking about where that might have to be done as a stopgap in EDAM, depending on how quickly any changes can get in. Are you able to track back in CAISO's use of the historical data to set the resource efficiency requirements, where that resource efficiency requirement might already be picking up load side impacts that happen during any type of event, kind of to ensure that you wouldn't be either double counting the impact on the load side, or in some instances, if you don't pick it up in an adjustment, just be missing the impact of it altogether.
Yeah, I mean, I think that's a spectacular question. And to answer you honestly, no, we have not done any sort of evaluation to determine like how that might be impacted in those other results. I did kind of have like a similar thought process along the lines of how a BA is different, a WEIM is different than, say, CAISO having a program. Because if we, just as an example, we have a program, and I'll use 100 megawatts as another example, as an example, again, just for ease of math. If we have a program that we call and say, hey, CAISO, we're expecting this 100 megawatts, and let's just say only 50 megawatts show up, right? Like, what happens if we took no other actions? And let's just say this was a participating resource that doesn't have telemetry. The way that I kind of see it, the BA kind of has three primary decisions that they can make. There's more, they can combine them and mix them or whatever, right? But one of them being is they do nothing and just ride the ACE, and at which point basically we would accumulate an advertent that would be accounted for and then had to be paid back to the system later, and there would be charges and stuff associated with that. The second one would be if they regulate to get ACE back to zero or within its bow limits per se, those would be actions that would be taken out of the market. And if we regulated on a resource that wasn't necessarily scheduled in the market to provide regulations, then we would also receive imbalance charges for those. And then the last one, of the three main ones, again, there's more things that they can do, but the three main ones that I had was they could also just throw in a load bias to get the market to represent that the resource didn't perform, and the market would pick up other other resources, either our internal generation or ETSRs, to accommodate for that. And so one of the thoughts and concerns that I had is similar to you about double counting is, let's just say we did something like load bias and the market picked up other resources, and then we had this as a participating model where we submitted our resource or our baseline data and whatnot, and it came back that it was understating 50 megawatts by 50 megawatts. It was supposed to do 100, but only 50 showed up, so we were 50 short. But then also in real time, other resources picked up and we got charged for those. So like, how does that all work out? That's kind of another question and a thought there that I have, around how this is going to work. And I don't really have an answer to that. It's just kind of something I've been pondering about. I don't know if anybody from CAISO has.
Well, I'll just close out saying I think that's all good considerations, and I think the encouragement would be that we try and get to the point of kind of testing the ability to represent these more directly in the market, and see how they perform, maybe with smaller quantities to start, but not wait until we have an absolutely perfect model to be able to start finding a way to bring them into the market. But I am curious, kind of what CAISO might think would be possible for being able to track back to where maybe the histogram is picking up load from a certain period, to see if that period it's picking up would have coincided with an event where the load would have already seen some adjustment or not. But really great stuff, and appreciate the effort PGE's been putting in here.
Thank you. Appreciate the comments.
Next, we have a question on the line from Luke Tugas. Go ahead, Luke.
Yes, hi, good morning. My name is Luke Tugas. I'm a consultant for the California Efficiency and Demand Management Council. John, thanks for the presentation. Very interesting. Just a clarifying question, and I hope that I'm not putting you on the spot. Regarding the 1, 2, 3, 4, 5, I think the fifth one down, potential to enable EIM entities the ability to adjust the resource schedule. Forgive my ignorance, but can you explain how it would work with the VER, or how the VER forecast adjustment works now, and how this would work within that framework?
Yeah, this is kind of a potential. It's not something that exists today. And so my thought here is, we provide CAISO with the forecast. Either like today we do an LFA model, or if we base scheduled it or bid it into the market, that forecast would kind of be basically embedded in that schedule or in that bid, right? We would tell the market, hey, I've got, again, use the 100 megawatt example. We've got 100 megawatts here and I'm bidding this in. What I was getting at is, you guys may not be familiar with this, but on the EIM entity side, for variable energy resources, so like wind farms and solar farms, we're submitting a 5-minute forecast for these resources that go out several hours in advance. And so, we've got a variety of forecast issues. They either lag, or sometimes we have bad data or whatever. So EIM entities were provided the ability in BAOP, which is a tool that only our balancing authority has. And inside of there, it has that forecast. And the BAOs can actually go in there and override the forecast that we're submitting from our vendors. And so that way the market can make adjustments. So like, let's just say we had, in my scenario that I was talking about earlier, where we have a 100 megawatt resource and only 50 megawatts showed up, we would still basically schedule it in CAISO like it was 100 megawatts. But then when we only seen 50 megawatts show up, this would give a balancing authority operator the tool to go in and say, hey, something happened with my DR programs and I only have 50, so adjust the 100 megawatts down to 50, and then the real-time market and this is the 5-minute and 15-minute market would pick that information up, and the next market runs and make its adjustments.
Got it. Great explanation. Appreciate it.
Yeah, no problem.
Next, we have a hand raised from John Rudolph. Go ahead, John.
Yeah, hi, thanks for the presentation, John. This is just a clarifying question on the proposal, but I think on one of the earlier slides, there was the point of getting RSE credit. And just to clarify, are you saying that if you're base scheduling it as a resource, you would like credit for it as the resource in the RSE, or is the credit only through a reduced load forecast by making by scheduling the resource?
So for like the base schedule method, yeah, I mean, I think that's something that we would have to discuss, but I think, yeah, it would be ideal if we could get the RSE credits associated that are properly associated with the resource types. I don't necessarily know exactly how that would work with the non-participating model per se, because I'm guessing we would probably have to set up some sort of characteristics for that to represent, like, to provide representation to what the resource is and how it's going to respond for the RSE credits.
Yeah, and I guess right now I guess the way the current process works, you either get credit for it via the load forecast or through an RSE credit, and you have to be careful not to account for it in both places. Otherwise, it's kind of a double counting issue. And so I think if you can kind of either go one way or the other. You get credit for it as a resource in the RSE, or you can get credit for it by reducing your load forecast that feeds into the RSE. But I think we would have to work through a little bit more how that part of the process would work to avoid a double counting issue, depending.
Yeah, that's a good point. And I guess it kind of depends on how the resource would be modeled, right? Would it be modeled as a generator, or would it be model it as a load? And I think that's something that I don't think I've discussed or talked through, just the idea of being able to base schedule it. So I think that, to your point, depending on how that's modeled, it would show up in RSE in different ways, and we would want to make sure it wasn't double counted.
Okay, thanks.
Thank you. Next, we have a question from Brandon Holmes. Go ahead, Brandon.
Hey, thanks, John. Appreciate all the thought and work that went into this presentation here. Just had a couple of things. First, I think this is Brandon Holmes with the EPS. I think we're pretty aligned with you in terms of the base schedule non-participating model. It would seem like that would work well with demand response programs that we have right now. And I know on the slide previous to this, it's framed as kind of an interim solution, but I think just a comment, we might, advocate for having it be kind of a long-term solution, or a solution that, continues on, just based on, our programs, and aren't necessarily well suited for participation in the programs that we have right now. So that's, I guess, just a comment there. And then also a question, whether you contemplated, I know for our programs, some of them are customer thermostat programs. And so leading up to the event, we often have some pre-cool impact, as well as after the event, some snapback impact. So just curious if you contemplated whether, in terms of the resource type, like an NGR type model might be appropriate, just based on your guys' programs, or whether you thought about that at all.
Yeah, good. Thanks for the comment and good question. Yeah, and back to your comment really quick. I was just thinking interim in terms of like getting it up quickly. Yeah, I wouldn't be opposed to having it long term. The only other thing that I was thinking of as well is the EDAM and how that works with EDAM, because I don't think base schedules are allowed in EDAM, so we would have to work through that as well. But not everybody is an EDAM member going to be an EDAM member right away, so it would need to be a longer term solution. And then I'm sorry, what was the other question again?
Just in terms of the pre-cooled snapback, and then kind of specifically around the NGR type model where you can represent both positive and negative values there in the base schedule.
Yeah, that's a good point. Yeah, I think we kind of talked a little bit about the different models, and I think NGR offers a lot of flexibility. And it's probably like one of the better model types to be able to represent this versatility. The only thing that I think that we were kind of thinking is if we keep using like NGR for all this stuff, we're going to end up with like a lot of resources that are just NGRs, because that's what we have for the batteries. And I mean, not necessarily opposed to that, but basically, you know, I think it would end up being NGR is going to be used for a large number of resources. But I think that like that general model and having the flexibility in there is going to be something that's needed for these types of resources, because they're going to have a lot of different characteristics. You've got, like you said, thermostat programs that are going to have pre-cooling, that are going to have snapback and stuff like that. So kind of need something that's flexible that you can model in there. So yeah, I agree that it needs to be flexible. I don't know if like NGR is the right thing to use, or maybe we have a variation of NGR specific for demand response. But yeah, that was kind of my thoughts on there, was maybe we have one set up specifically for DR stuff, but kind of based on the NGR model.
Okay, yeah, no, I appreciate that, and that's kind of where we're at too. Just not, I guess, locked into the NGRs per se, but the flexibility piece I think is important from our perspective as well. So again, thanks a lot, John. Appreciate it.
Yeah, no, thank you.
Last question we have first a comment from Helen Lowe from SMUD. Helen Lowe wrote that SMUD is advocating for both so that we can use one versus the other, or both depending on the context and the characteristics of the program. And then she asked to hear about John's intention for this comparison of options. Is it either or can both be available as options? And then afterwards, she was hoping to hear from CAISO's perspective of having both as available options after John speaks on this.
Yeah, thanks for the question there, Helen. I think, you know, from my perspective, just based on the fact that we're not, it doesn't work with all of our customer programs, right? The third one from the bottom, the participating model doesn't. So it would be nice if we could have or create a participating model that did work with all of our programs, but since it's likely not to be, we would still need a way to represent those programs as well that can't be participating. So I would see this as kind of both, with a caveat that we're signed up for EDAM to go live next year, and I don't know how that's going to work out with EDAM.
Yeah, thanks, John and Helen. I think from the ISO perspective, similar answer to John Kitchen. I think there's no reason why both couldn't be available. Obviously not for the same resource represented in both programs, but I think we're seeing the new participation model that John went over as fairly similar to proxy demand resource with a few key differences. So I don't think that wouldn't mean that both couldn't be available for participants to use. So.
And I guess I had a question, John, in terms of more of a clarification. There was some discussion about resource efficiency evaluation, deployment of that. What, I guess in my mind, the big question I have from an expectation standpoint, if you were to utilize a base scheduling, non-participating model within a newly, developed one, what is the expectation of when it would be considered within the RSC? Only when it's deployed, or always being provided some type of credit for these programs? This is kind of unclear to me how you're viewing it.
That's a great question. I mean, I think if it's base scheduled from like my perspective, and I think if we went with the non-participating base schedule model, I think it would probably should only get RSE, honestly, when we are actually scheduling it. I don't know how. I think other people, if you go ahead and go to the next slide for me really quick. So this is something that I wanted to talk about really quick as well. And there's a comment on here about why we didn't go to PDRs, and this kind of feeds all into this. So this is 4 months of summer last year and our recorded temperatures in Portland. And so, like, to answer that question, I would love to be able to get RSE credits all of the time for the programs. But like, as you can see in here in summer, and I kind of have these color coded. So the red is the high temperatures above 90. So it gets darker as it gets hotter. And then orange are in the 80s, greens in the 70s, and blue is below 70s. And so you can see, like, we don't, like last year, we did not have a whole lot of hot days. So I don't think that it would be accurate to say that we should get RSE credits for programs that are really dependent on it being hot. There might be some other programs, like say maybe customer EV programs or customer battery programs, that should be able to get RSE all the time. But like residential thermostat programs and things like that would not, we wouldn't really be able to call on them for their full amount, or unless we provided CAISO with like a forecast, an estimated forecast on a daily basis, saying, hey, if we were to call this event, this is what we would expect today for this weather conditions.
And just for context, the question that John is referring to is a question from Eric Leone asking, has PGE considered PDR? Why is NGR more appealing than PDR? And then there's also a follow-up question asking, and will this change if joining EDAM?
Yeah, thanks for the question. And so we have looked at PDRs, and the point of contention with the PDRs is really that the way that they're set up and framed today is they require a specific PIMS, a specific baseline methodology. And if you look at this, again, at this slide here, you can see like the days that I have highlighted in blue. So like in July on the 5th, the 8th, and the 9th, and then in August on the 8th, and also in September, we had a couple of events. So the majority of our like really hot days is when we called these events, with the exception being on the weekends, because at the time we couldn't call a lot of our programs on the weekends. We're working on changing that. But so anyways, what I'm getting at here is, if you think about like a 5 and 10 or a 10 and 10 day baseline methodology, I don't have 10 days that are in the 100-degree range when we called on those days that we called those events that are like days, right? And so we don't, like, our baselines that we use are different. Like one of our programs, like our energy partner programs, the customer can actually sign up in that program and sign up for, like, I think it's 3 different types of baseline methodologies that we use, and all of them are kind of weather adjusted, and basically they're different than what CAISO has implemented today. And so when we ran down trying to do PDRs, it was really that we just, our baseline methodology wouldn't work very well with what the way that we do baseline methodology to get our accurate results today doesn't really align with what CAISO's requirements were. And so our calculations wouldn't be aligned with CAISO, and our analysts that we had working on it basically said that there was going to be like a significant difference between the two. So that's one of the main reasons why we didn't. And I also think that the NGR model, and I need to look at PDRs a little bit more again, but I think that the NGR model is a lot more flexible and allows to represent more characteristics and stuff than, say, just a basic PDR model. And I don't know if CAISO, if anybody, I'm not an expert on the PDRs. I looked it up, like, it's been like 3 years ago or so since we tried to do that. So I don't know if you guys have any more details around like the specific details, PDR versus NGR.
I don't have any specific, I guess I didn't hear the actual question between the two. There are significant differences between PDR and NGR. One being NGR is really, PDR again is that separation of load that's being scheduled to be served, and then the PDR is a representation of that curtailment, an economic representation of, you know, a pseudo supply representing the curtailment economically, whereas NGR is really it's scheduled, and then curtailment is represented as bids within that NGR as to serve me or don't serve me at a certain price.
And John was, of course, speaking to the challenges they're identifying with the baseline, some of the baseline methodologies that we've covered in the past with PDR. You know, there are weather matching baselines. I think that this calendar does a good job of illustrating how even that would not be able to draw like days to produce a sort of relevant baseline from that methodology. So.
And I think, John, too, within your chart, you represented registration as probably another item, although you did talk about within your presentation the ability to, you know, the desire, the need to represent movement within your programs, additions and subtractions of participants, which is facilitated through our registration process. But I know that there's some cumberness to that, some process within the current registration process that may need to be considered, you know, within a participation model, maybe foundationally, if you think about PDR, but then some of these different processes around PDR needing some adjustment. So that's kind of, was there something else in terms of PDR on the measurement methodologies and then the registration? I think too here you recognized previously that with some of your programs, maybe the price signals aren't there, which a PDR would just definitely be on a, you know, economic price signal for dispatch. I think you represented that in a previous presentation.
Yeah, thanks. No, it was just Eric was asking why PGE and APS was, but call that why PGE was interested in NGR, or why it was more appealing than PDR. So.
Okay.
Thank you. And we actually received a follow-up response from Eric Lyon in the chat saying, Renew Home strongly advocates for implementation of the holdout type control groups that PG&E presented on earlier in the DDEME process, which would address some of these issues, end quote. And we do also have another hand raised. from Colin Smith. Oh, it looks like
Yes.
the hand was just lowered.
No, I
Does
lowered
anyone?
it to ask the question.
Yeah. Go
Thanks,
ahead.
Christina. Yeah, I know we've had several discussions about the PEMs and past working groups and efforts to change them to be more accurate, reflective of the actual performance of resources, especially in situations like the one that was just highlighted. I'm curious, John, you said that your analysts saw that there'd be a big difference in performance between, how PGE measures performance in their programs and how they would be measured under PDR. Could you give more details on on how PGE measures performance in its DR programs and kind of what the main differences are?
I am not the expert in that field. I would have to probably pull Katie into a conversation. Maybe we can ask and see if she can present on what we're doing and how they're doing it. From my understanding, like it's kind of a mixture of different things that they're doing, where they're doing some weather matching, they're doing some like 5-day baselines and a different variety of things to get to our measurements. But I don't have those specific details. We had a consultant that provided that to us, and a part of that may have been some misunderstanding as well, because like in the tariff, there's only there's only a few things that are showing that are authorized in there, and then as we've discussed, there's actually like a list of, I don't remember how many you guys have authorized, like there's like a list of a couple hundred or something that you guys pulled up before. So
Thank you, John. And I'm not seeing any other questions coming in at this time. If you wanted to continue your presentation.
well, that's actually all that I had. The questions guided me through. The next slides are just some of the slides that I had from before, and I didn't really have anything else other than it's the same conversation as this slide. So I am good. That's all that I had. Thank you. I really appreciate you guys giving me the time and also working on this work group. So thanks.
Thank you so much for your presentation. And does anyone in the room at CAISO have any feedback for John before we move on to the next agenda item?
I think I wanted to go back to the clarification because there was the discussion about NGR as a model. And, the understanding in terms of use of NGR as a model within our distributed energy resource aggregation policy. So the policy is DERA, where you can represent the VPPs, which were compliant with the FERC Order 2222, which also incorporates both GEN as well as what we term as distributed curtailment resources that are measured through some type of baseline methodology. That's kind of the policy over. Yes, we use the NG model. In the market to represent that particular resource that's following the requirements under a DERA. So I just wanted to kind of give some clarification on that. The other clarification is that DERA then, in terms of a WEIM participant, there would be a load forecast for their firm load that, but this, if you were to carve out the representation of the load that has this non-firm capability and represent it within DERA or as an NGR model, you're representing the load being served, and then at what point in time you don't need to serve that load economically, from an economic standpoint. So I think it's a very detailed nuance of these different participation models, DERA, supported by an NGR model, and then PDR, which separates the two and is just the load is being served under a load forecast by the load serving entity, And then you're able to separate that out and just represent the curtailment portion of that overall load separately under PDR.
On that note, Helen from SMUD, we see your comment, it's a good comment, that you think the NGR is good at representing the limitation for behind-the-meter customer programs, but think it's worth the exercise to do a holistic side-by-side comparison of the pros and cons of driving the new participation model from NGR versus PDR. Thanks, Helen.
From an understanding perspective, do these behind-the-meter programs have total energy limitations similar to like an SOC for a conventional 4-hour storage resource?
If you're asking me,
trying to capture the bidirectional nature and no kind of forbidden zones by using the model. And sorry to interrupt.
Oh no, you're fine. I was gonna say, yeah, I mean, there's different characteristics, like somebody mentioned earlier, like handling snapback. I don't necessarily know off the top of my head how you can represent that in an NGR model per se. Maybe you can show how it ramps in or something like that. Ramps in and ramps out to represent the snapback and pre-cooling. But there's also some, there's going to be some battery programs as well on the customer side, and there'll be some programs may have some different limitations and restrictions. Not all of them, but there can be some programs that have those sorts of characteristics.
That is helpful clarification. Thank you.
Yeah, and I do see Helen's comment too. I think that's a good, exercise, NGR versus PDR, as we discuss this, developing options and alternatives. And maybe we could have that at one of our next working groups to discuss further. Okay, thanks, John.
Yeah.
Thank you, John.
Thank you, guys.
Next, we will be hearing from the California Department of Water Resources regarding participating real-time load bidding from TJ Vargas. Go ahead, TJ.
Hi, Christiane. Thank you. Can everybody hear me okay?
Yes.
Okay. So my name is TJ Vargas with the Department of Water Resources. I really appreciate the CalISO team fitting us in to present. I just want to mention that DWR has been advocating for participating load to bid into the real-time market, and we've also been advocating for bidding increasing load, which that subject falls into the demand side bidding. And recently there was an edit to the discussion paper that kind of separating the two. So this original presentation was built for PL bidding into our participating load bidding into real time, and also demand side bidding. So there's a couple elements in demand side bidding in this presentation, and I'll highlight them to kind of not bring to your attention. Sorry about the last minute change, but we'll move forward with the best we can. Next slide, Christina, please. So overall, right now, the California Department of Water Resources, or CDWR SWP, is supporting exploring models to allow participating load resources to bid into the real-time market under the enhancing demand flexibility options, which is item number 6 in the discussion paper. And we look forward to working with the CalISO and stakeholders on this process. Next slide, please. So overall, on the State Water Project background, the State Water Project is the largest single load within California, ranging from 6 million megawatt hours to over 9.5 million megawatt hours, depending on the water year. Right now, under the participating load agreement, The State Water Project has 2,900 megawatts. Depending on certain conditions, that full number isn't available, but we have a good amount of demand resource capacity. The availability of participating load very much depends on the water year. Also, the State Water Project serves many water districts that supply 27 million or supply water to 27 million customers and farmland. We also have 5 hydroelectric dams, 3 pumping generator plants, and 21 pumping plants. And for the topic today, we are mostly focusing on the capabilities of the pumping plants for participating load and demand response. Next slide, please. So participating load, it was mentioned earlier, but participating load is an additional DR model along with PDR, RDRR, and HDRA. For the graph on the right, the CAISO Department of Market Monitoring was very kind to put together some numbers on the top 20 days with restricted maintenance in their DR performance report. And I just wanted to highlight for kind of the average of June to September last year, DWR had about 550, sometimes more capacity available to offer. So you can see out of the other DRs, participating load makes up a significant portion, which I don't think really gets highlighted from time to time in the traditional DR discussions. So how does DWR State Water Project participate in DR today? So we mainly use the aggregate participating load model. In doing that, we submit 2 bids for the same trading day, one for the day ahead self-schedule with an energy bid price and another for non-spinning reserves. Our real-time participation is limited to non-spinning reserves. For an example, demand reduction. And just highlight it before, we provide a significant amount of DR available and resource adequacy. Next slide, please. So just for this slide, please excuse the last 2 bullet points for improving system reliability and support seasonal grid efficiency. Those are more reflective for demand side bidding, and also please excuse the slide at the bottom. What are kind of the opportunities for real-time load bidding? So we want to align the incentives with the real-time needs. So similar to other DR models, allowing participating load in the real-time market shifts, relying solely on capacity payments in the day-ahead market. We have flexibility to provide participating load in the real-time market. And this is kind of what we're talking about a little bit on the slide right. So you can see a majority of our rewards are in capacity versus a very small amount dispatched in real time. So we believe switching to giving the availability to participate in the real-time market will adjust some of these opportunities. To the second bullet point for optimizing resource utilization, we believe participating load participation in the real-time market allows for a more efficient resource optimization, and it enhances the ability of DR to true up in real time, better aligning demand with supply and reducing reliance on less flexible, more expensive generation. Essentially, really, just as anybody knows, procuring energy in the day-ahead market is not as accurate in the real-time market, and so we're advocating for a better optimization. For the third bullet point for reducing system costs, the real-time DR participation of PL helps avoiding triggering the dispatch of costly peaker plants during high demand periods, and particularly in the summer. So, by leveraging PL as DR, the system can avoid inefficient, expensive generation, providing overall lower costs. Next slide, please. So this is our draft problem statement. Currently, PL has no mechanism for bidding in the real-time market, and participating load should be able to be changed to allow in the bidding in real time. So like stated before, the current market incentives limit participating load to non-spinning reserve and contingency events. Participating load bidding in the real-time market allows optimization between the day-ahead schedule and the real-time schedule. And real-time load bidding can, again, as highlighted before, help lower system costs. Next slide, please. So like we mentioned before, please excuse bullet points efficiency and competition. Those are more related to demand side bidding. So how does real-time bidding fit into the working group scope? For the discussion point, it's we're looking to explore models to allow participating load to bid into the real-time market. So for feasibility, participating load is already integrated into the CAISO system, and it has a proven track record to perform in the market. The bidding in real time was a function in the CAISO market back in 2009. Market changes unfortunately kind of changed that circumstance, but it's understandable. So PL is also easily implemented with minimal changes. And for liability, PL performs pretty well as scheduled. And bidding in real time increases available capacity and supports grid reliability. Next slide, please. So for conclusion, the State Water Project has a good amount of participating load under capacity. And currently right now, we just want to hit home that participating load doesn't have the capacity to bid into the real-time market. And we're advocating for changes to allow that. And I do want to address, I think it was Colin Smith who wanted clarification on Tony's question on whether participating loads have access to wholesale prices when they schedule load in day-ahead market. So the answer is yes. Participating load does are subject to the local LMPs, and they're also subject to the transmission access charge. And that's my presentation. Does anybody have any further questions on real-time bidding or participating load?
Thank you for your presentation, TJ. I'm not seeing any hands raised at the moment. Does anyone from CAISO in the room have any feedback for TJ?
Yeah, we just wanted to address, I think that the earlier question also asked about the pump storage and the transmission access charge. So participating load, as was described, is not waived from transmission access charge. However,
the
storage.
Pumped hydro would be similar to how like an NGR closed loop battery system would be.
Exempt from tax.
Yes.
So we just wanted to put that out there because I think it was an open question earlier. Was there any other questions in the room? CDWR?
I'm not seeing any more questions. So with that, we'll move back to our other main slide deck on slide 18, please.
But I just want to say, appreciate the presentation. I like the way that you drew out the principles within your, and how it met those principles. That was great. I think now it's Jimmy to.
Yeah, thank you so much. Do we want to maybe take a break before we dive into the problem discussion? I know we're a little bit early, but we did build in a break before getting into the final stretch for discussion. So maybe we can reconvene at 11:45 if that sounds good.
Just 11:30 would be.
Or 11:30.
Yeah.
30-minute break.
Great. We will reconvene at 11:30 Pacific time. Thank you. Hi, everyone. Welcome back. We hope you had a good break. Next, we will go to Jimmy Bashara regarding the draft problem statement formation and general questions. Go ahead, Jimmy.
Thanks a lot, Christina, and welcome back, everybody. We'll just want to say once more how much we appreciate Portland, NCPA, and CDWR, for the presentation. We're now going to sort of continue on that narrative as we, sort of flesh out the issues and really what are the problem statements, right, that we're honing in on, similar to how we did for the PEM discussions. And again, the whole goal is to align on what the actual issues and impacts and problem statements are that is being addressed, so that we can potentially have something to work with for policy development, which again, we are targeting by September of this year. So looking forward to making good pace in the upcoming working groups. And with that, maybe we can start off with the first presentation we have from NCPA. So Christina, I think we had a problem statement slide if you want to go to that. I think if you scroll up a little bit towards the beginning after the NCPA placeholder, it was right after that.
Yeah, so that should be slide
14?
14, yes.
Yep, there you go. So the CAISO sort of took a stab at the first draft of the problem statement, and really looking forward to having a collaborative discussion and flesh this out. And, we anticipate, taking the remainder of this session, obviously, and then to the extent we might want to continue the discussion for the next working group, we're definitely open to that, of course. So, so just kind of reading off the slide here, based on Tony's and NCPA's presentation for hydrogen electrolyzer participation. What we felt might be a good starting point is sort of, the current CAISO market participation models may not best account for the unique components / characteristics of certain large loads when paired with or in parallel operation with supply resource operation. So I think two important distinctions there is certain large loads. We didn't want to get too technology specific in anticipation that, we are technology agnostic, so we want to make market rules as accommodating as we can and with the least barriers as possible for all technology types. And then again, focusing more on the supply side, resource operation here. So any comments from Tony, others, questions, clarifications around this suggested problem statement?
I'm not seeing any questions coming in at this time, Jimmy.
Okay,
I just,
yeah, go ahead.
Yeah, I just want to make sure, because I think from Tony's presentation, I really understood much more clear that this wasn't a large load generation kind of hybrid type situation, that it's really about more of the desire to move into an energy storage construct. I think we put it in the problem statement when paired with a supply resource. Sometimes I get confused a little bit about it being worded that way because we have a lot of large loads coming in with a supply resource that's serving that load. But what I took from his presentation was it was more of a movement toward an energy storage kind of construct. Which would be, currently, is more of that seamless operation between load and gen. And I just want to see if Tony could confirm that.
Yeah, any thoughts? We see you on still, Tony. Not sure if you're still around, but if you are, we can unmute you and appreciate any thoughts around that. Because we did draft this problem statement, obviously, before hearing today's discussion, yeah. So that was helpful that you clarified that, Tony. So I think we're looking to tweak it, right? This sentence here to be more consistent with that.
And I'm also wondering if we need more than one problem statement, because it did sound like there may be a desire to move from a load participation into the more of an energy storage dynamic. energy storage participation. So I don't know if there's still, if current load participation models also don't meet the unique components and characteristics, or if this is really in the pairing of its load and its ability to also provide generation.
I think
storing that fuel basically to like a battery.
Right. Tony recognized, I think, that there was one of the models would be more relevant for this working group.
Okay.
And
Which
then
is the load.
Yes, exactly.
Okay.
And then it may be appropriate to kind of have a different venue, perhaps for the further discussion of the NGR kind of seamless approach. But yeah.
So this problem statement is more about the seamless approach. So if
Perhaps.
we want to work on something within this working group, do we need another problem statement focused on load characterization?
Right.
Or inability?
Hey, Ansel, I apologize. This is Tony Zimmer. I apologize. I'm back. Yeah, I know you guys flipped this slide and a bunch of folks came to my office. So, but I'm here in case questions come up. So I apologize.
No problem, Tony. Yeah, thanks for the heads up. I think our question is, you know, to the extent to which you feel this problem statement on the screen captures, you know, NTPA's proposal into the catalog, and what we're thinking is maybe based on what you presented, this is sort of the problem statement related to the NGR-like seamless approach of load and generation within sort of the co-located or combined resource. And so would be open to the idea of revising or adding another problem statement related to, you know, sort of a load-only electrolyzer model, and how our current options do not accommodate that.
Yeah, and just generally speaking, and that was kind of our thought, is that, electrolyzer technology on itself has flexibility to be used in a variety of different manners. And so it seemed, at a high level, maybe appropriate for kind of a standalone electrolyzer that may be used truly as kind of a responsive demand type, air quotes, resource. Maybe that, belongs in this particular track. But I think some of our initial thoughts is when you start thinking about more of a complex interaction whereby the electrolyzers are being used in conjunction or directly with other supplying resources, more for the purpose of kind of developing a kind of a storage based tool, that perhaps there might even be other ongoing initiatives or perhaps a new initiative that speaks to that specific kind of model characteristic may be more effective, as compared to treating that as purely a kind of a responsive demand position. So I think, maybe splitting it into two problem statements to kind of reflect those two unique operating conditions, could be appropriate, because if, like you noted, in terms of a, kind of a different storage / NGR or whatever mechanism that looks at that more parallel operations, if that would be better to focus, as a derivative to this one or somewhere else that we would support that concept. But yeah, so I think there are the different operating setups are, I keep using that word, different enough that it may justify kind of two problem statements. But that's just me talking out loud.
Yeah, thanks a lot, Tony. That's extremely helpful. That's where we were sort of going before you just kind of hop back on, was, is this one appropriate to capture the parallel operation nature and sort of that NGR-like attribute that you just mentioned, and whether that is the case, is it going to have a home here in this initiative or possibly elsewhere, right? We can certainly, those are great questions. And then, yeah, it sounds like we can try to flesh out a second load-only problem statement for the electrolyzer.
Yeah, because I guess in that context and using a general hypothetical example is if, say in the future, you know, industry in general started developing electrolyzers kind of for maybe the initial purpose of producing fuel for, you know, transportation purposes or otherwise, but that with operating characteristics of the facility itself, it could also, you know, provide services in the context of the wholesale market. So, you know, kind of separating those two objectives where one electrolyzer installation may be used more kind of to supplement the underlying purpose of, you know, reliability support and generation support for ISO operations as compared to another one where maybe the primary focus is, you know, it's a gas station, but has the operational capability to provide services based on a more kind of limited, you know, limited focus, I guess.
Okay, thanks.
Yeah, and I think too, the only other question I had, you know, having had, you know, many discussions on this type of load and its access to the wholesale market, are there other problem statements and maybe they, you know, in terms of what we should, from an ISO capability, lead to allow for more market access, or do you think that that's, I don't know if I'm stating this, or, you know, I'm just wondering, we're very technically focused, and from a policy perspective, see if there's any other problem statements outside of the very technical focus of the problem.
Yeah, no, I appreciate that question. I think one thing that's kind of been, you know, an issue, a question and an answer question in our mind that if, for example, a large electrolyzer installation was intended to be operated in a certain fashion, maybe again using my kind of selfish example in that parallel operation, would that facility be viewed more as a supplement to generation, kind of similar to a battery energy storage system, and therefore, in terms of its, you know, consideration for interconnection, you know, would something like that be more appropriately, you know, considered as part of the kind of the TPP and ultimately the interconnection process via ISO versus if you had a fairly large, you know, load in the form of an electrolyzer, you know, generating, you know, hydrogen producing facility, you know, the loads on these can be fairly significant, and, you know, does that get processed as a load more in conjunction with an associated PTO's interconnection process or something? So that was kind of one of the questions in the back of our mind, is if the initial intent of this is potentially to act as kind of a so-called inverse, you know, wholesale generation or wholesale participant, what would be the appropriate mechanism through which, you know, any types of interconnection studies would be considered. But again, that's just a concept we were throwing out there. So whether that has any influence on other, you know, kind of problem statements, you know, I'll kind of leave it there, but I'm happy to answer any questions on that.
So essentially, for that second problem statement that we're discussing, something like, you know, there are current barriers to current participation models that don't adequately account for like the limitations of an electrolyzer, something like that.
Yeah, I think. Yeah. Well, I'm sorry. Yeah, I think something to that degree would be fair.
Okay. Any other thoughts? We don't see any other hands up, but this is what we're looking for. We're going to, you know, be updating our discussion paper with what we heard and taking written comments, of course, but, you know, any other input that anyone else has, thank you, Tony, to add on to that is extremely helpful at this stage.
Thank you.
Jimmy, we did receive a question in the chat saying, I'm curious to know if Tony, TJ, or John have thoughts about whether the PDR load shift resource structure is suitable or applicable to this discussion. Would there be merit to looking at PDR, LSR in context and exploring potential adjustments to that model to facilitate the hydrogen and other larger loads.
Yeah, thanks, Christina and Chris. I think just as a very high level, LSR model has kind of a curtailment and consumption paired resource, and the consumption resource to increase load is only triggered during periods of negative prices. That's kind of the high level description of that resource. We don't currently have any PDR LSR resources in the market today, I believe. But yeah, perhaps something to look into, and if any of our panelists want to respond to that, feel free.
This is TJ. We have not looked into that.
Yeah, great comment. Thank you for that. Any other thoughts on that comment specifically, or more generally for this slide?
I think the other thing about PDR LSR, I mean, that is a retail load. And I guess it could accommodate wholesale load as well. I don't think there's a restriction on it, but it was recognized in the development of that we were talking about aggregation of retail load, providing access to the market at these negative prices for consumption. But it doesn't eliminate the retail settlement component of that if it is a retail load. I guess if it was a wholesale load, then yeah, it would be the full wholesale load. I don't think it would work with wholesale load. I think it would be, we'd have to use it for other, we have, it's not set up for wholesale load.
Okay.
Thanks, Jill. So yeah, that's good though, to get us thinking about if we could potentially change it, or whether we need a new model to account for the electrolyzer load participation on its own. Great. So we can definitely craft that second problem statement about, you know, the barriers or the limitations of electrolyzer participation, you know, don't really neatly fit into the current model, and we can maybe tweak it from there and provide the discussion paper. Any other comments, thoughts on that approach?
I'm not seeing any other questions or feedback coming in at this time.
Okay, great. We can always come back to this since we have time, you know, as we discuss the other problem statements, but maybe at this time we can move on to the next draft problem statement. Christina, if you scroll down, I think after the NCA, or I'm sorry, the Portland placeholder.
Yeah, that should be slide 16.
Yes, thank you. All right, great. So again, we appreciate John and Portland for their discussion. So we sort of parsed out, you know, looking ahead at their presentation and hearing the discussion today, you know, seemed to make sense to parse out in 3 different sub-problem statements for this one. And apologies for the title slide, shouldn't say demand side bidding. We can correct that. But essentially, John did point out a few different issues that we saw, at least. So again, supply side is what we're focusing on here. And, you know, John sort of illustrated how the economic signals really don't align with the current market incentives, is what we picked up from all of that for that first bullet. And then the second bullet, obviously, John hit on nicely, and our John Rudolph touched on the manual load forecast adjustment process and how that may not be the most efficient or ideal, as John illustrated. And then the last one, obviously, is, you know, after John showed us the calendar days of the weather and, you know, talking about how there really is no neat baseline that can fit. You know, that third one there is what we're trying to capture with that. Current PEM options do not recognize alternative measurement methods used by WEIM entities for performance evaluation. So we think those are a pretty good starting point, at least, to capture, you know, Portland's presentation and the general problem statement for this theme. Any questions from John or anybody on that, on this slide?
I don't have any questions. That looks like a good summary. Thank you.
Awesome, yeah, thanks, John. Again, we'll update the discussion paper with these problem statements today and circulate that online for stakeholders along with a comments template so everyone can have more time to comment. But really looking for just quick thoughts after we're fresh off the presentations for any edits or potential other problem statements that we might want to include here.
I'm not seeing any questions coming in the chat or any hands raised at this time.
All right, great. Maybe these are a little bit more baked than the first one, so I think that was our feeling internally. And hearing no comments, I hope that's the sentiment. But again, feel free to raise your hand or comment as we get to maybe the next. Oh, I do see a hand from Eric.
Go ahead, Eric.
There we go. Hi, everyone. Yeah, just wanted to, this is Eric Lyon from Renew Home. Just wanted to sort of voice some support for that third one, but maybe with like a slight reframing, which is, you know, can we sort of learn from the alternative measurement methods that are currently being used by the WEIM entities and get those, you know, listed as PEM options in CAISO for PDR. So I think somebody else asked, you know, what the current methodologies that PGE is currently using, and be curious to hear more about that maybe at a future time. Thank you.
Yeah, thanks for that. That's a good suggestion to take what's out there already and maybe have that as a sort of sub PEMs to explore. Great. Any other thoughts, CAISO or anyone else online? Anyone from the CAISO team online that want to chime in? All right.
I'm not seeing any hands coming in.
Thanks, Christina. Okay, well, we can always come back to this in the limited time that we have left, but maybe the next problem statement, the final one, we can pull up here. I think a couple slides down.
That'll be slide 18.
Thanks. So going off of CDWR's presentation, we thank you all again. You know, we appreciate how you all, of course, spelled out, I think, what you see as the problem, right? I think we kind of hit on that a little bit more broadly with this sentence, but I'll read it out loud for our draft problem statement that we think might be a good starting point, is that participating load resources cannot fully bid demand into the real-time market or decrease energy consumption due to barriers to its participation within wholesale demand response and due to modeling limitations, which would otherwise allow it to better respond to ramping needs by shifting demand, for example, when the water conditions permit. It sounds like it sort of encapsulates what CDWR was spelling out, right? That participating load needs to have more of that be able to fully bid demand into real time, which it doesn't really do today. So it sounds like, you know, maybe modifications to the participating load model is what we're sort of going towards. Any other thoughts, comments on that? CDWR, anybody?
This is TJ. That looks pretty good. You know, if we have any feedback, because there's people that are more technically capable with our system than I am, we can provide some feedback too, but I think generally that looks pretty good. Thank you for the work.
And, you know, recognizing that in your presentation, TJ, you also had a little more extensive list of problem statements that were more specific. And so we can also take a look at those and determine if we need to integrate those into the next discussion paper draft.
Yeah, I think the thing that jumps out to me is just ramping needs. It sounded like there was just a desire for full real-time market participation and just allowing for that. Maybe just not a ramping, but more of an economic participation.
Right.
But
yes,
I think
correct.
with with the comment there, when water conditions permit, starts to invoke some constraints, you know, constraints that would have to be considered in terms of, you know, a model or changes that we might have to consider within the participating load model.
Mm-hmm.
Yeah, generally this looks good. I'll take it back to the team and kind of refine this and be able to get back to you guys specifically. So, but I think in general it looks pretty good.
Great. Yeah. Yeah, definitely. As Ansel mentioned, you know, maybe updating the discussion paper with the language from your presentation to kind of further refine this problem statement. And I do see a couple of chat comments from Colin
So
Smith.
these were related to the previous problem statements. I let Colin know I would pass it along to the team. Did you want to review it now? If so, I can go ahead and read his comment.
Yeah, go ahead, Christy. I think that's fine to go back and clarify that.
Sure. So Colin said, given that we're working to address many of the shortcomings that PG&E identified with PEMS elsewhere in this working group, we should note that those problem statements also apply to WEIM entities as well. And he also noted that this is the approximately 5 to 6 problem statements we developed around PEMs.
Thanks, Christina. So Colin, let's go back to your comment about learning from the current WEIM baseline options and kind of throwing that in to refine the problem statement for further exploration, or did you mean something else by that? Sorry, Colin, if you're there, if you're able to raise your hand, then the operator can identify you.
Not seeing his hand going up at this moment or any follow-up response.
Oh, I don't know,
Colin
operator, if
noted,
you're able to identify Colin's line.
Yeah.
Yeah, could we please unmute Colin Smith's line? He's having trouble raising his hand.
Thanks. Looks like I'm unmuted. Yeah, this is just connected to, I guess, the past discussions we've had on PEMS and the problem statements we've developed specifically around PEMS have, some of them have looked at addressing some of the issues I think that John identified that PGE sees with participating in their resources as PDRs. And so to the extent that any of those issues are being addressed in other problem statements, just clarifying or making taking the steps to call out that these problem statements, if the solution would ideally be applicable to WEIM entities as well. And so definitely learning from PGE about the alternative baseline methodologies they're using, but also making sure that any changes to CAISO's baseline methodologies are also applicable to WEIM entities. I imagine that would kind of happen by default, but just kind of drawing the connecting thread between this discussion and the discussions that have been occurring on PEMS elsewhere.
Yeah, that's good that you pointed that out. There's definitely intersection, right? Potential intersection with the previous PEM discussion and
which is applicable to PDR. So yes, as it applies to PDR.
Right.
So there was, and that was the distinction we made under the PEM discussion, that we were really talking about the PEMs for PDR. And in the presentation, it again kind of highlighted the differences between an economic kind of participation model, and if we extend, the PEMs to a different participation model, yes, that would be extended to we won't, maybe it's not called PDR, but it's a participation model that would, the desire for these different PEMs or capabilities would be extended to. But the distinction with, at least from my viewpoint, there was a distinction as to a very WEIM-focused participation method, and then a broader participation method. And then there was some comparing and contrasting to those two, where the PEM really came out in the, you know, in-market participation model, where, yeah, it would be applicable to. So that's kind of, I just want to make that of note. And yes, it does. It kind of filters from the other PEM discussion we had.
Thanks, Jill. Hopefully that clarified for you, Colin and folks. It's a good comment. All right. So just any other questions on that last one for participating load? Any other thoughts? It looks like, you know, we've got a lot to work with between CDWR's presentation and the draft problem statement on there, and I'm looking forward to any other input.
I'm not seeing any other questions coming in at this time.
Okay, great. Well, since that is we're nearing the end of our presentation, just want to be sure, any other thoughts, comments, generally, just working group process, anything substantively that we discussed today? Happy to take last questions before you wrap up.
We touched on the schedule at the beginning as well, so if folks have thoughts or questions about that, we can clarify also.
Oh, okay.
Unless that.
I think you're going to go over the schedule.
Yeah, we're going to go over the schedule. I think we may have mentioned it, but we'll go over it again in more detail on the next step slide. So on that note, so today, you know, thank you all again for the discussion for enhancing demand flexibility market options. We heard a lot of great thoughts, and we've got some nice draft problem statements to sort of integrate into our discussion paper, and you all can look forward to that being posted soon with a comments template. And then as you can see, you know, we do anticipate hitting all of these next themes in the next few weeks. So I think it sounds appropriate for the next working group maybe to sort of wrap up this discussion, and any other thoughts that CAISO might have or any other folks might have, we can give that chance and opportunity. And then the next working group, we will likely move into the next theme on the second half of that, into the reliability-based DR. So we do appreciate anyone's thoughts that would like to present on that theme. We'll be sure to notice it as we have every working group meeting and solicit input for presentations or any other, you know, suggestions as we go to that one. And then as you can see, the next three themes after that: economic demand response, expanding demand-side bidding options, and distributed energy resource participation. A lot to get through here in the next few months, but we are making good progress. Any questions on this? Oh, I do see a comment, a couple comments from Helen, from SMUD. I think from an EIM entity's perspective, it is less about the BA. Okay, going back to PEM. So from EIM entity's perspective, it is less about the BA PEM is better than CAISO PEM or another BA PEM, but more about giving the entity the degree of freedom to decide on the PEM that is best for their programs and context. Very, very good, reasonable comment there, Helen. I think we agree with that. And then you also added the reason is that the entity bears the consequences of failure from both reliability and economic perspective. Yes. So it's our job to give you guys.
That's the difference, WEIM versus in BA participation.
Yeah, that's a great distinction between reliability and economic, that delineation there. So I think that's what we're hitting on with these EIM versus BA PEMs, right? But you're right, you know, the participant is left with the option to choose, and we should reduce the barriers as much as we can and give you guys that flexibility. All right, well, any more comments on, thank you, Helen, on this slide or anything else?
I'm not seeing any other. Oh, go ahead.
Oh, sorry, Christine, I do see one more comment from Nadia. Nadia, if you could identify which entity you're with, that'd be helpful. But Nadia says, thank you, it'd also be helpful to see how EDAM participation would fit into the discussion moving forward, for sure. Thank you, Nadia from PAC. Thank you very much for that. Yes, definitely agree, and we'll take that in mind as we discuss the next working groups.
What does that mean? EDAM.
And maybe if you want to.
EDAM? I mean, do we need are we looking for a very focused discussion on EDAM participation in terms of options available. I'm not sure.
Sounds like, Nadia, if you want to maybe expand on that, but it sounds like you're just curious how EDAM participation would impact any of the items that we're discussing from a problem statement perspective or potential solution perspective in this initiative. Is that fair?
Yeah.
Yeah.
Yeah. Hi, yeah, this is Marty from PAC. Yeah, it'd be helpful just to have that lens as we're moving through participation models and how those would be either on the load side or resource side moving forward.
Okay, thank you for that.
Thank you.
And then you see another comment from Perry. Perry, if you could identify which company you're with, that'd be helpful. But Perry asks, are PEM additions or modifications within economic demand response topic? Yes. So we discussed PEMs, the first few working groups, and that is all on the table for economic PDR. Thanks, Barry. All right, seeing no further questions, maybe move on to the next slide. All right, Christina, take it away.
Thanks, Jimmy. For next steps, a comment template for feedback regarding the updated discussion paper will be noticed prior to the next working group. And all meeting materials and notices are available on the Demand and Distributed Energy Market Integration Working Group webpage. And if any of you have any other questions, feel free to reach out to me directly at cgimura@CAISO.com, or you can always reach out to us at ISO Stakeholder Affairs at CAISO.com. Next slide, please. Now I just have a few announcements today before we wrap up. Here you can see some of the meetings taking place at the ISO this week. Next slide, please. And here you can see market simulations occurring this week. Next slide, please. And lastly, for insights into the ISO grid and market operations, be on the lookout for our Energy Matters blog, or you can always subscribe. Here you can see our latest blog post regarding strengthening reliability through year-round gas-electric coordination. And with that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for informational and convenience purposes only, and all meeting materials are available online, and the video file will be posted shortly. Thank you, and we hope you have a wonderful rest of your day.
Thank you, everybody.